Hi, this is Randall Schwartz, host of Floss Weekly. This week, Guillermo Amaral joins me. We're going to be talking about Prometheus, a soup-to-nut monitoring, alerting, reporting program that'll take care of all your systems, no matter how many you have. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Randall Schwartz and Guillermo Amaral. Episode 357, recorded October 7th, 2015. Prometheus. This episode is brought to you by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS in the billing section for a $10 credit. And by Braintree. Even the best mobile app won't work without the right payments API. That's where Braintree V.0 SDK comes in. One amazingly simple integration gives you every way to pay. Try out the sandbox and see for yourself at braintreepayments.com/floss. It's time for Floss Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at StoneAge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day and not aware of it, projects you might want to download right after this show and go play with. I am coming to you today from my Silicon Rainforest apartment, and it's a little gray out there, so hopefully the light's coming through reasonably well. Let's go ahead and bring on my co-host, Guillermo Amaral. Welcome back to the show.
Hey, Randall, how's it going?
It's going well. It's going well. And for once, we have no sun right outside the window. It's a rainy day. I think that also means that the leaf blowers are going to stay away, which usually plague my show about midway through. So, and also all the windows are closed because it's not that warm out here anymore. So I'm pretty happy with all that. So yeah, it's been a good day. Life's been good. I'm actually here for a week in Portland, which is sort of unusual. I usually head out. Oh yeah, so my next show's actually going to be from here too. And then the show following that will actually be from down in good old Mexico, but that's getting way ahead of myself. So let's see. We have a great project today. We've worked somewhat. We haven't worked hard at all to get these guys, and I'm sorry, but they've been very cooperative, yes. But we've got Prometheus on. Prometheus is appears to be sort of a monitoring, data gathering solution, originally written for the SoundCloud. Oh, I probably got the wrong one. SoundCloud. Yeah, thank you, SoundCloud people. But now as an independent project of its own, we have representing the project, we have Julius Volz. I hope I pronounced that right, who's going to be talking to us about that. He's sort of the lead maintainer and developer of Prometheus. What do you know about scanning this already there, Guillermo?
Well, not really. As you know, I haven't done much, system admin stuff for a while, but I did like the movie. Does that count?
Sure, that's fine. That's fine. Also, it looks to be something, this is the same problem you have with all your monitoring systems, with all your data gathering systems. Like ZipRecruiter, my primary day client these days, has something like 100 machines in the cloud. And you've got to gather all the data from all these and bring them together in some sort of displays and some sort of way to do alerting if something is off base. And it looks like Prometheus is sort of a soup-to-nuts solution along this area. It also has the feature that's written mostly in Go, which means that you don't have a lot of binary dependencies or library dependencies, I should say, when you install the project. So anything more on that?
No, not really. I am planning on trying to use something for this for a new client we have, but I'm still looking. So hopefully this project will convince me to use it instead of something else.
Okay, good. Well, that sounds pretty cool. Well, before we bring Julius on, I have a very important announcement. Whether you're an experienced code warrior or just getting started, you need flexible, reliable, and affordable hosting. DigitalOcean provides developers with Droplets, which are virtual private servers that can be customized and deployed quickly to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you can think of with full root access. I myself am a DigitalOcean customer. I found out about them back in at Scale, different conference, in in February and found out they were running FreeBSD as one of their options. And I said, that's my OS. I'm definitely going to start using these guys. So DigitalOcean is built for developers and used by over 400,000 of them, as I said, including me. You can deploy and configure your Droplets via a streamlined control panel or a simple API. Choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD, as I said. A one-click install allows you to quickly deploy apps like Django, Docker, Drupal, LAMP, GitLab, MediaWiki, Node.js, WordPress, Ghost, Magento, OwnCloud, Ruby on Rails, and more. The servers can have up to 20 CPUs, 64 gigs of RAM, and 640 gigs of SSD hard drive space. Very, very fast disk. You can deploy servers in regions all over the world with gigabit speeds and 99.99% uptime. Full-feature DNS management easily manages your domains, or you can use dedicated IPs. And web console access is with HTML5 or SSH, SFTP, KVM, VNC for virtual desktops. And it's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. I have verified that multiple times. So DigitalOcean has incredibly affordable and straightforward pricing. Servers start at only $5 a month. There's also hourly pricing available, starting at less than a penny an hour. But we're going to make it so you can get started today and deploy an SSD cloud server for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code FLOSS for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do. That's DigitalOcean.com, and once you sign up, enter the code FLOSS in the billing section for a $10 credit. We appreciate DigitalOcean's support of Floss Weekly. And now let's go ahead and bring on our guest. Julius Foles, welcome to the show.
Hi, great to be here.
Very cool. And where are you speaking to us from?
I'm speaking to you from Berlin, Germany.
Ah, so it's more like, what about 5 p.m. maybe?
It's 5 p.m. and it's already kind of getting dark and getting cold.
Well, it's just getting lighter for me. So you're sending the sun. You're sending the sun my way. Thank you. I appreciate that.
Yeah.
Awesomely cool. And so why don't you give us sort of the 30,000-foot view? What is Prometheus and what problem is it trying to solve?
Prometheus is a time series database and systems monitoring tool, or also service monitoring tool. And it really tries to be a whole ecosystem for getting metrics out of the things that you care about, whether those are machines or services, storing those metrics, being able to query those metrics with a nice dimensional query language, but also being able then to alert people when something goes wrong and to show nice dashboards. So it's kind of... It aims to replace things like Nagios, Graphite, StatsD, Ganglia, and so on in that space, and takes a much more modern approach to cloud-based monitoring, where things are much more dynamically being shifted around in the cloud. You have hundreds of instances of different types and so on. And yeah, the way this came about was that when I joined SoundCloud in 2012, I just came from Google as an SRE there, and I had some limited experience with monitoring. But if you then leave Google, you feel kind of naked in terms of what open source infrastructure software is available for you. And another person, Matt Proud, who actually also just joined at the same time, joined SoundCloud at the same time, also came from Google, felt very similarly, felt even stronger than me about this, and really convinced me to start building a monitoring tool from scratch. First, that kind of happened in our free time, but we also really wanted to tackle the problems that we saw at SoundCloud. SoundCloud at the time was using a mix of StatsD, Graphite, Nagios, Ganglia, and a bunch of other tools actually, and they weren't working so well anymore for what we wanted to do because we already had this kind of Heroku-style in-house cluster scheduler with hundreds of different types of microservices and thousands of instances in total. And not only do you want to monitor the machines of that cluster, but for each of these microservices, you need to know about each of their instances, which are currently behaving well, how are they doing, and so on. And you need to know, you need to get very clear insight into, for example, if there's a latency spike, is it only one instance that has a problem, or is it, a global one? And Prometheus's nice dimensionality model allows you to do that, to measure that quite nicely, and then ask for that information in the way you need it, when you need it.
Wow, great! That's a great overview. I appreciate that. So some of those other projects you mentioned, like we've had Isinga and Nagios on Actually, I don't think we've had Nagios. Maybe we had both of them. Anyway, like Xinga, it's only mostly just gathering the data. It doesn't really have like a long historical database. It has a little bit for uptime measurements, but nothing beyond that. And so you have to pair that with some of these other things that you talked about. So what I've seen traditionally done is organically grows up. People go, well, now we need some way to kind of see what the historical thing is on this. Now we need some way to put a nice dashboard so we can glance over it a moment, or use it in a crisis to see what's actually going sideways. So Prometheus, from what I understand, though, is integrating all this. It really is like one soup to nuts sort of solution. Can you talk about how that design came about?
Yeah, sure. To be honest, we were quite inspired by what we had as tools at Google, and those, of course, then were not available in the free and open world. But yeah, so we're very inspired by that, and the whole architecture to any ex-Googler or Googler will look very familiar, which is, I think, also one thing that really helped with the adoption of Prometheus. And the way it works is, so I think it's really centered around collecting everything as a time series. And a time series is really just a metric name plus a set of key value pairs that uniquely identify that time series. So you might have something like HTTP requests total, and then you have some labels on it that say instance equals, host port. The job name is API server, and the handler on which this HTTP request event happened would be the /messages handler, and so on. And Prometheus is really about getting any data into that sort of time series that are collected usually in a 10 or 30 seconds interval, sometimes shorter, sometimes longer. It's configurable. And then making that really efficiently and nicely queryable. And the way So Prometheus believes kind of in the church of pull, so to say. There's different advantages and disadvantages to that. It's kind of a religious issue, whether you push metrics to your monitoring system or whether you pull them. And in some situations, pull is a bit annoying. Like if you have heavily distributed targets on the open internet that you want to get metrics from, that's a bit of a firewall annoyance. But for the usual environments that we target that are kind of, you're in your own virtual private cloud or your own data center and you can scrape anything in there. You have the central Prometheus server, or, you'd have one per team or one per service, depending on your scaling needs and your organizational needs. And that would pull from the things that you care about, any metrics. And these things that you care about could be three different kinds. What we really recommend is the first kind. If it's like your own service that you have full source code control over, we really recommend to put white box metrics in there and really expose metrics over an HTTP handler directly from that service. Things like queue lengths, HTTP request counts, and so on, start times, and then expose them directly with one of the Prometheus client libraries over HTTP. That's kind of the recommended best case. But you might also have systems that you want to get metrics out of that you can't instrument directly, like things like the Linux kernel or HAProxy or Nginx, and you maybe don't want to go into the C code and hack a metrics handler in there. So for that, we have what's called exporters, and these are little sidecar jobs that you just run next to whatever you want to actually instrument. So for example, next to an HAProxy, I would have a little HAProxy exporter. And whenever Prometheus asks the HAProxy exporter, hey, give me the current state of your metrics, it will actually transparently in the background ask the HAProxy in its native metrics format for the current state of things, and then hand that back to Prometheus. And we have a similar exporter for machine stats. It's called the node exporter. Has nothing to do with Node.js, just node in terms of a node on a network, right? And many, many, many other things. So there's like a huge list of exporter. MySQL also is a very active one right now. So no matter what kind of third-party system you have, it's usually really easy to bridge metrics into Prometheus land with that. And then finally, the third kind of thing that you might want to get metrics from is something that's just way too short-lived to be scraped, to be pulled from. And for that, we have that should really only happen for things like batch jobs, for example, that run once per day, maybe process a bunch of users, output a success status, and maybe the number of users processed. For that, we have a little push gateway job that you run, and that batch job can then push metrics to the push gateway, and the push gateway kind of acts as a metrics cache and just holds on to the latest pushed state, and then Prometheus can scrape that. And I guess with pull, a big question is, how are targets even discovered? And the way this works in Prometheus is that, like in the very, very naive scenario, you can just configure them statically. You just give a list of, this is my host, this is my port, this is my endpoint. Prometheus expects a certain format in which the metrics come. And then, Prometheus will go out and query those endpoints. But that breaks down in any, normal modern scenario where things just kind of float around in the cloud on a Kubernetes cluster or, dynamically scheduled. So for that, we have various kinds of service discovery integrations. So right now we support Kubernetes, Marathon, Consul SD, and some others, including one where you can write your own with where you write the targets dynamically into a file, and Prometheus watches that file and just dynamically updates its target list to scrape. So in any case, you should be covered, hopefully. And
well, that's all, that's all the time we have. Thank you for talking about... No, just kidding. I appreciate the long answer. But I'm thinking now, I've already got like 5 questions to follow up here already, and we've just barely scraped the surface. We've just scraped the data scraper part of this. But right. I want to a couple questions out of there. You're not actually reading like every HTTP hit into some central database, are you? Are you doing some summaries already on the server side?
Yeah, a really important thing to understand, and what is also important for people who come and want to use Prometheus, they need to understand that Prometheus is not a log store. It's not an event store. So you lose the information about every single event. You don't have that anymore. That's something like, you can store that in Hadoop or in Elasticsearch or InfluxDB. What you store in Prometheus is really aggregated time series. So what you would store, for example, is... let's go for the case of just a simple HTTP event, HTTP request metrics counter. Yep. You would just have a little client library object in your HTTP server, and every time it handles an HTTP request, all it does no network things. It just increments a number in memory. And that number might have some dimensionality attached with it. So, for example, like the handler that the HTTP request was about, and so on. But otherwise, it's really just increment a number, and that's really, really fast. If you compare that to something like StatsD, where you really proportionally to the user traffic that you receive, you send out UDP packets to your StatsD server. Why not just increment a number? And the other thing that's happening here is that we do not do any client-side rates. We just count up. So even if you miss a scrape and there was a short spike in a rate or something, you would still get the updated counter state at some point at the later scrape that then succeeds. So the philosophy is really to expose the data as raw as possible from on the client side, on the instrumented service, and then do any computation in the Prometheus server. So for example, I have this HTTP request counter. It just, let's say it has no dimensions. It just goes up and up and up and up. Every time that Prometheus comes by and scrapes that service, it will only get, for that metric, for that time series, the latest value of that counter. What is the counter right now? No history. So, and that value it takes, stores it in the database, and says, okay, at this point in time, the counter is this. And if you just graph that, it will look really, really boring. It's just a line that goes up forever. And you can't really see how fast, what's the rate and so on. So for that, we have functions like the rate function, which will tell you how many requests per second you're getting. And then if you have dimensionality, you can then sum over the rates by certain dimensions, but not over others. Like if you only want to see what's the total per instance or the total per job, a job kind of means a service in Prometheus. So yeah, that's basically how it works. But we don't only have counters. That's really important. Like there's other metric types. The most obvious other one is a gauge, which just measures something that can go up or down, like a temperature or a queue length. And then we have more hybrid metric types, two of them, which are the summary and the histogram. And a summary really actually calculates client-side quantiles of, let's say, request latencies or so on. That's really tracked in your service. But the problem is you can't really aggregate, like average over, let's say, the 99th percentile of multiple instances into a total 99th percentile. So for that use case, if you need that, we have histograms, which are just kind of cumulative histograms, bucketed histograms, where you just count on the client side for each latency range, how many requests you've gotten so far, and expose that to Prometheus. Prometheus, again, internally just stores it as time series, and then again gives you a set of functions to ad hoc over any dimensional combination that you care about, give you percentiles, or yeah.
Yeah, just so I understand what you're saying, when you're saying dimensions, are you talking about something along the order of, like on a web server, is it a 2xx or 3xx or 4xx response? Can I break those out, that dimension?
Exactly, yeah. So dimensions, Prometheus gives you some dimensions for free when it scrapes your target. So it will tag any time series with the service name, which we call the job in Prometheus, and the specific instance of that service, like the process. If you have a service, usually it might be replicated 100 times or so, and you really want to be able to drill down into the specific instance that is having, let's say, a latency spike, right? So these are two dimensions that get attached by the server when it scrapes automatically. And then the client, the instrumented service, may choose to also add additional dimensions. So if you look at something like the node exporter, if it gives you the CPU usage, it just also is a counter that goes up and up and up forever, the number of seconds of CPU used. But it also gives you that not only as one big number, but per CPU. So if you choose to, it actually looks kind of funny. You usually see that, you know, the first CPU has higher load than the other CPUs on the machine and so on. So you get quite some nice dimensional insight. The important thing here, again, is that these dimensions should still be used in a nicely bounded and defined way. So you shouldn't put stuff in there like a user ID, you know, of which there could be potentially be millions, or an email address, or track IDs. You know, that's a surefire way to kill your Prometheus server immediately.
Speaking of killing your Prometheus server, does this work well in a HA environment?
Right. So the whole architecture there is, so as you already said, it's written in Go. Prometheus takes a kind of simplistic approach. It's natively, explicitly not a distributed system. So you run it on one node, and it has local storage, so it's completely autonomous. In the alerting case and so on, it can calculate any rules that are needed for alerting, no matter if any distributed storage is down or has problems or so on. But of course, one node can always go away, right? That's 101. So if you want HA, just run two identical ones. And there's actually one nice thing that the pull model has, is that since the services themselves have no idea where monitoring lives, you can bring just up an identical Prometheus server that's just doing exactly the same job, and it will pull in exactly the same data. And yeah, so basically you can bring up as many of them as you want. You can even do that easily on your workstation or laptop if you're in the VPN, and start getting production monitoring on your laptop. So that's really great for experimenting too. Yeah, and then these Prometheus servers, for alerting, I think alerting is the most important use case where you want something like high availability. If you have two Prometheus servers generating the same alert, these alerts again are also dimensional. So they have an alert name, and they have, you know, the instance that they originate from, and any other dimensions that you choose to preserve. Then the alert manager, of which you usually only run one in a company, deduplicates these label sets and sees, okay, these 2 alerts from these 2 Prometheus servers are actually the same, so I'm not going to send you 2 notifications. And so I haven't gone into the alert manager yet. That's kind of this central clearinghouse for notifications that you run in your company, which it's still one of the most experimental components of the ecosystem, but it's what we're attacking right now to make it really stable and well working. And that allows you to correlate all the different alerts from different Prometheus servers, maybe even have dependencies between them so that one doesn't notify you in case another one is firing. You don't want to alert on an instance being down if the whole data center is down or something like this. That allows you to configure the actual alert routing based on the labels of alerts. Where should they actually go? Where should an email or a page go or a Slack notification? It has like many, many different notification mechanisms by now. Most of them were contributed by very nice contributors. So, yeah.
So it's a little bit like having something like PagerDuty implemented directly inside it about not having scaled things at the right time or notification schedules?
Yeah, almost. It doesn't have as much functionality. It has different functionality. It has some overlap. So we use it to send alerts to PagerDuty. And in PagerDuty, we actually have like the telephone numbers of people and the actual who is on call when, and so on. Whereas in Alert Manager, you really just say alerts that match these and these and these labels, please send them to this PagerDuty service. And then within the PagerDuty service, all this, escalation policy stuff is handled and so on.
Oh, okay. Okay, and so let's talk about what I sort of see as the second phase of this. So that you've got all this data that you've gathered, and I see now like a query language that I can run against that. How is that used? Is that used to define alerts? Is that used to define the graphs? How is that language used?
So I would say 3 main use cases there. Definitely, so ad hoc queries are one big thing where really when things go really wrong at the night maybe or something, you want to be able to drill down quickly into where exactly the problem is, right? You see, maybe you get an alert about latency being high in your service, and then you want to drill down, is it really just one instance? Is it, why is it? What other metrics are there that look weird and so on? So that's kind of this ad hoc exploration case, which is very nicely supported with an expression browser which is built into the Prometheus server itself. But it's really not for building, that expression browser is not really for building persistent dashboards and things that you can share with others, have on wall screens and so on. So for that use case, the dashboarding use case, we have several solutions. We have either PromDash, which is a GUI-based dashboard builder. So the Prometheus dashboard builder. And it really allows you to click together graphs with all the kind of usual graphing settings that you would expect, even different expressions from multiple Prometheus servers in a single graph, put it on a wall, share it with others. We also now, there was experimental Grafana support for Prometheus, and that has just been merged into Grafana Master. So from today or yesterday, I think, there's native full support for Prometheus in Grafana, which is really nice because Grafana is already heavily in use everywhere. And I mean, we are really more back-end developers than front-end developers, so we're really happy that we're getting this support from a dashboard that's already really has the community behind it. And then this third use case. Actually, on the dashboarding use case, there's also another technology that you can use, which is templates, HTML templates that are served directly from a Prometheus server and have access to the query language. So they can actually build a dashboard dynamically based on what metrics are currently there and so on. And then, as you mentioned already, the last use case, the third one, is really alerting. And the nice thing here is really that in the alerting language, you can use the same query expression, query evaluation language as you use in exploration or dashboards, meaning you can really formulate your alerts in such a way that they mix and match the right data in the right way to give you the right dimensional output. And outputs of an alert will also just be labeled time series. So you really know if something alerts, which instance has a problem, or, depending on how you're aggregating in the alerting expression.
Well, that sounds really. Oh, sorry, go ahead. Guillermo has a question. I think.
Well, yeah, I did actually. Although I wanted to bring it a little bit back to the other end. I'm not sure if that's okay, but I can send you back to the UI set in a second. You did mention before that you had you were pulling all this information from a client, right? So in this case, how exactly are you guys doing that securely? Do you have a backend server that actually listens for a link from Prometheus, the server itself, and then that scrapes all the clients? Or are you actually maybe SSHing into the server and scraping each one when you want to get an update?
So usually, there's different strategies. Let's say you're in your own data center and you're in a trusted environment, and you can afford to, if you have some internal web API servers that are not even reachable from the outside world, you would just put another endpoint on there. /metrics is the default, that will expose the current state of Prometheus metrics. Now, there's other cases where you might have a service which gets public traffic, and in that case, you have different choices. So either you can, what we at SoundCloud do is we have 2 ports on each service. One is the publicly reachable port, and another special port for just the telemetry. And we don't route any public traffic to the telemetry port. But there's also different ways of doing this. You could have a common path prefix that you filter out at the perimeter, for example, for the metrics endpoint. Or if you have metrics endpoints really distributed on the internet and you need to scrape them with some central Prometheus, that's not really the use case that Prometheus is geared around. It's more of this, you're in your own cloud, you scrape your stuff, the Prometheus server is behind the firewall already. But if you want to do that, you need to put some kind of auth in front of your metrics endpoints. So let's say you have a node exporter for the machine metrics, and you have machines on the internet, and you don't want anyone to just go to the metrics endpoint and get the metrics. You would then put some Nginx with SSL and basic auth in front of that and configure Prometheus to use that. Or it also supports client certificates and so on.
Okay, I was wondering that. So if you're already behind the firewall, I guess you can just open those ports to anybody inside in your subnet or something, right? So it should be kind of secure. And that was digging into my brain for a little while. So who else is using this besides SoundCloud? Do you know?
Yeah. There's a bunch of companies now, some of which I know about, some of which I don't know about. Others, I don't know if I'm supposed to tell about them. But there's definitely some that are really worth mentioning. So Google has started instrumenting Kubernetes natively with Prometheus metrics. The Kubernetes tech lead, Brandon Burns, he's a big fan of Prometheus. So the Kubernetes master at least is instrumented with that, and I believe the kubelet and a couple of other components. CoreOS is doing the same with etcd, maybe also other components, not sure. DigitalOcean, actually, it's funny because you just had an ad about them. They are, I think they're also pretty public about this. They're pretty much switching to Prometheus internally now. There are other bigger companies that I don't know if I can mention them right now, but there's like a bunch of companies in that space adopting it. So it's really, really exciting to see this. And we just launched this. So history-wise, it has always been open source and public on GitHub, but we never really made noise about it until January of this year. And since then, everything has kind of exploded. We've been very lucky with contributors coming, and we just actually hired a full-timer at SoundCloud based on his Prometheus contributions, Fabian Reinhardt, and he's already he's an amazing coder. He's rewritten like half of Prometheus, and it's way better because of him. But we also have core maintainers not only within SoundCloud but in different companies, and always happy about contributions there.
So is there any way to know how stable Prometheus is now? I get with all the clients you mentioned, I'm guessing it's really stable now at this point, right?
Yeah, so the version is still 0.16.0, or well, that's the version we're about to release, which is kind of, the normal thing these days. But we really hope to, at least that's the plan right now, to release a 1.0 release this year. And for our intents and purposes, it has in recent times been really stable. There's always still the occasional little glitch or bug or so on, but people have been reporting that it's mostly working really well. So the version is more about feature stability and API stability rather than how well it works right now. So I think on the feature and API stability front, the one thing that we're still going to change is how Prometheus talks to this new alert manager, which we're currently redoing. But otherwise, the whole system is kind of almost complete. I mean, there's still some bits and pieces missing. You can actually, if you go to Prometheus.io, head to the roadmap section in the docs. You can see some items there. But yeah, I mean, I would say it's definitely production ready. I would use it nowadays, of course, in my own, if I had a startup or something, yeah. But even in a bigger company, I mean, if DigitalOcean feels good enough to pick it up after quite a lot of research, and a lot of other companies also after quite some research decided to go for it, I think it's already says good things, yeah.
Well, we have a whole lot more questions to keep asking, but I've got to pay the bills here for a second, because this episode is brought to you by Braintree. Developers around the world have embraced Braintree V.0 SDK as the easiest way to add secure mobile payments to their apps and websites. No matter what the payment type, Braintree accepts it. Apple Pay, Android Pay, PayPal, Venmo, credit cards, even Bitcoin. And if something new pops up, Braintree will support that too. It's the same payment solution used by Uber, Airbnb, and GitHub, so you know it scales. It has simple, secure payments, code you can integrate in minutes. And developers, we got you. Don't worry about taking days to integrate your payments. With Braintree, it's done in minutes. The Braintree code supports Android, iOS, and JavaScript clients with SDKs in 7 languages: .NET, Node.js, Java, Perl, yay Perl, PHP, Python, and Ruby. Elegant code with clear documentation and only 10 lines of in-app code typically. Braintree gives you an easy way to accept multiple payment types with one integration. Integrating it into your app is as easy as inserting a few lines of code. Try out the sandbox and see it for yourself at braintreepayments.com/floss. And we really appreciate Braintree for supporting Floss Weekly. So I'm wondering, what's it like to set this up, though? I mean, is it an all or nothing approach? Do I just install a bunch of apt-get packages and then I have to instrument everything I've got? Or is there a transition plan if I've already got something in place like Icinga?
Yeah, there's definitely a transition plan. And we actually use Icinga in combination with Prometheus for quite a while. Now we're switching to the native alerting. So both on the side of getting metrics out of existing systems, you might already have things that already produce metrics in some format. Let's say you have StatsD is a very common format. There is we have these exporters, and we have something called the StatsD bridge. You just run it next to your StatsD, and just let StatsD replicate any of the packets it gets to the StatsD bridge, and the StatsD bridge will then convert those into Prometheus metrics. Now, the StatsD bridge has a bit of a less powerful data model, so there's a way to map things into dimensions in the StatsD bridge. So that's one possible way. Then on the alerting side, you might not choose to use Alert Manager. You might choose to use some Nagios plugin that just queries Prometheus for some query expression and then alerts based on the outcome. We did that for the longest time at SoundCloud. Luckily now switching, it's going to be much nicer with the native alerting actually. On the setting things up side, it depends on what you're into. So you can build it from source pretty easily. It's Go. We have binary tarballs that you can download. We have Docker images. And there's an independent other company which is now offering nightly Debian builds of the major components of Prometheus. And there's also a contributor working on official Debian upstream packages for the various Prometheus components. I don't really have any experience with those because as a developer, usually I just build from source or get the tarball. But it's one static binary and one config file, and it's like boom. So Prometheus itself, you download it. You need one little configuration file. You just to test it, you could just configure it to scrape itself, because it also exposes metrics about itself in the Prometheus format. And that's all you need. And then we'll just start by default in your local directory into a data directory. It will put metrics. Of course, you can point that anywhere you want. And yeah, so that's basically it. You just download the static binary. That's probably the easiest way.
Well, that does actually sound super easy. So I was going to bring up, how can somebody just test this out if they want to see how the UI works, how it looks, how fast it interacts with your actions, like how fast you can set up the scraping. So I'm guessing they can just download the Starball config, play around with the config file. Is there any place they can go to learn how to configure it?
Yeah, definitely. There's on Prometheus.io, if you go to the docs, there's a getting started section, which includes the download step, the install step, making Prometheus scrape itself, and then also starting up some example targets that, there's actually the web page. Cool. And yeah, it takes you to through running some example targets that produce like bogus metrics about HTTP requests, and then you can scrape them, and it gives you a couple of examples about the expression language. And we also have a much more elaborate version of this getting started as a workshop that we're going to give next week at Velocity in New York, VelocityConf, and also end of the month VelocityConf in Amsterdam. And that's already that's written up as a huge markdown file, and we probably want to also integrate that afterwards into the main doc site. So we also then have, how to use the alert manager all in one. Like, we already have separate components for that, but it would be nice to have like one large tutorial integrating everything, dashboarding, alerting, how to instrument your service, and so on.
Have you by any chance already stress test Prometheus to see how many I guess clients you could scrape at the same time, or how many services you can check?
It's like, I think it's the last question in our FAQ, and it kind of depends on the shape of your data, but usually we have not been bottlenecked on the scraping itself, but on storage ingestion. And on a single node with SSD and modern beefy big node, I think how many? 32 cores, 64 gigabytes of RAM. We get, I think it was 360,000 samples per second sustained ingestion rate.
Wow.
So with a high dimensionality, so you really need that, because you want to be able to track down metrics to specific, instances or a path within an instance. So you get many, many time series. So a typical Prometheus server in one single scrape, if it's a big beefy machine, can easily do, 1 million or multiple millions of time series.
What would be the feature you're most excited about coming soon? I kind of peeked at your roadmap when you mentioned it, and I see you have like long-term history. Is that one of them, or maybe you have a secret one in there?
I think the alert manager rewrite is definitely, for me, exciting, because that's been always experimental, but a very, very important feature. Long-term storage too, but it seems that, right now we have support for, so Prometheus itself only stores time series in memory and on local disk. And it's a custom built local disk storage, very optimized for time series and compressed and so on. But still, if you have like very, very high traffic, high ingestion rate, you cannot store more than weeks or so. If you have a small server, maybe you can store months or even years. But if you have these really big servers, at some point your disk gets full. And also, it's not meant as a durable forever storage. For that, you really want to have some kind of distributed backend storage that replicates data properly and so on. And so right now we have experimental write support into InfluxDB and OpenTSDB, but we don't have the path yet to read back that data. So through the Prometheus query language, and that's probably not going to come before 1.0, but might come later. That would be really great to have, but we also haven't found the ideal backend storage system yet. InfluxDB, at least in my latest tests, still like ingestion rate, storage sizes, and so on, haven't fully convinced me yet, but it's improving. So I'm continuing the benchmarks. I'm actually planning on doing a benchmarking comparison blog post there soon. OpenTSDB has a couple of problems. So it doesn't support the full data model. You can't use any kinds of characters in tag values, for example. You can have a maximum of 8 dimensions of 8 tags on your time series and so on. On Prometheus, you frequently have more, and then you can't store that data in OpenTSDB anymore. So yeah, it's kind of a question. It's not really solved yet, not really answered yet what we will do long-term about long-term storage. But for now, some users really care about that, and other users really are happy with, having maybe 2 weeks of data or a month or a couple of months of data in their Prometheus itself, and running 2 of them for the durability aspect, and then just replicating data, to one of these other systems, but not being able to directly read it back through Prometheus. That would be kind of the golden solution that maybe happens one day.
I'm not familiar with some of those databases you just mentioned, but I think I'm more familiar with RRD Tool, and RRD Tool has the disadvantage that as you trail the data off, it becomes more and more aggregated. Is your intent to always have all the raw data available for all these systems?
So in Prometheus itself, in the local storage, we basically have downsampling after some time as a non-goal right now. It wouldn't actually help that much given the compression we use, and it would be quite complicated to implement because our storage is very heavily focused on just appending, never go back and change any data that's already been written. So in the local storage, that's at least for now, a non-goal. In the long-term storage, you can basically do whatever you want, I guess. If you put data into InfluxDB and then instruct InfluxDB to downsample it in a certain way, that could work. I don't have a lot of experience with that, though.
Okay, and also, I was thinking back to the earlier example we were talking about getting started on this. If you just did a graph of Prometheus's uptime, would it just always sit at 100%, even if you killed it for a while and brought it back because it's no longer able to monitor itself, or would there be gaps in the graph?
There would be gaps in the graph. Well, it depends. Okay, you usually wouldn't have Prometheus just monitoring itself, right? You'd have a meta-monitoring Prometheus. So we have meta-monitoring, and that's just another set of Prometheuses which scrape all the Prometheuses in the company and gather metrics from them and page us if they are down. And optimally, you don't update the meta-monitoring at the same time as your main monitoring and things like that.
Yes.
But yeah, they would show gaps in the graphs, and the Prometheus data model, the way it collects samples, it's different in RRD Tool in the way that RRD Tool expects samples to come in at very specific configured times, right? Every 10 seconds or every minute or whatever the RRD file is configured to. And in Prometheus, since scrapes kind of happen at random times, although they're semi-regular, you never really know when samples come in. We just have, for every sample we store a millisecond precision timestamp and float 64 as the sample value. No matter if your data is actually just a constant integer or 0 or 1 all the time, internally it will actually compress really, really well. And I think the float 64 integer precision is so high that you could have a counter incrementing 1 million times a second for hundreds of years or so. We have that in the FAQ somewhere. Without hitting any precision issues. So at some point, you'll be so high, I think at 2 to the power of 53, where the next integer that you could represent with that float would be more than 1 apart from the previous one. And that's a use case you don't usually hit. And because you have local counters in every process, and they never, ever, ever even get close to that. And then you take rates over those counters and then sum the rates. So you never actually have a number that gets close to that in Prometheus.
Yeah. And, okay, so I'm curious now, is this What's the governance of this like? I mean, who gets to decide what's in the next roadmap? Is it sufficiently distancing itself from SoundCloud now that it's sort of a community effort?
Yeah, I mean, it has an interesting history because it already started outside of SoundCloud. Matt, who started the Prometheus project with me, started already with some first client library and bit of server sketches before he even joined SoundCloud, then got me on board. And that's one thing. But then also, we have core contributors from other companies. So it has always been kind of a mushy situation where it's not completely clear, but where pretty much from SoundCloud side, they're very cool about it. They are totally fine with us running it as a completely open source project. And it's really not SoundCloud controlling the way Prometheus goes. The only way that might be currently the case is that the majority of the kind of core maintainers are currently working at SoundCloud. And they have, I mean, that's currently Fabian, Björn, and myself. We're probably the core people doing Prometheus at SoundCloud. And we form currently the majority. So, if we all feel very strongly about the direction that Prometheus should go in one way, then usually it will go that way. But I have to say, that's usually not tied to what SoundCloud wants. So that's pretty cool. And yeah.
Okay, and I've got to channel Simon Phipps again, even though he's not here. What's the license did you choose, and do you require a contributor agreement?
It's Apache 2 right now, and right now we don't require a contributor agreement yet. We might go for that just for kind of safety reasons in the future, but for now we don't have that yet. Yeah.
Well, then with an Apache license, a really fluid license like that, it's probably never needed to have a contributor agreement. Or is all my English going away? I guess we're pretty bad. We're almost out of time. Is there anything we haven't asked yet that you wanted to make sure our audience is aware of?
No, just go ahead, try it out. And if you're interested in contributing, definitely head to the community section of our site. There you'll find our ISC channel where we're really, really active, actually. Our mailing list, our issue trackers, and so on. Especially we need front-end help, of course. But any kind of back-end help or just users helping test, use it, and so on. That's always very welcome.
Cool. Well, it's been wonderful, but I sort of went, oh no, we're going to run way out of time. So it actually wasn't bad. I think we got pretty good coverage on this, and I'm excited by this. I am actually going to go represent it. Okay, I must be getting close to the end of the show because I can't use English anymore. I'm going to definitely tell ZipRecruiter and Insight Cruises about this because I think it's the kind of monitoring system from beginning to end that we really should be working with. So that's just fascinating. I'm glad you were able to come on today and talk about Prometheus with us. Thank you for joining the show.
Yeah, my pleasure. Great to be here.
Very good. That was Julius Volz, who is describing to us the wonderful Prometheus, found at prometheus.io if you're just listening to the show. Oh, wait. Oh, Julius, come back. Oh,
I'm still here.
Okay, good. I'm sorry, my audience would start yelling at me, and I just got whispered in my ear that I forgot this. I have two questions I got to ask every guest, so bear with me on this. What's your favorite text editor?
Vim.
Yes, again. Good man.
See,
good man.
Why did I even bother asking that question? I know the answer to that now. I'm an Emacs guy, so that's why I'm always like, whatever. And what's your favorite programming language?
Go.
So you got to do that too. How about scripting though? Go's not really a scripting language, is it?
Scripting. I have to say, I read your books about Perl when I was a child, but I haven't done Perl in a long time.
It's okay.
It's okay, right? Recently, scripting. I try to not do scripting anymore. I'm too stupid for it. It just breaks on me all the time, so I need a compiler. But recent scripting language that I did was Python. I do prefer it over Ruby because it has less magic and is more explicit about many things and has fewer ways of doing things. So I always enjoy the more straightforward way.
Yeah, that makes sense. Okay, well, thank you once again, and thank you for the people who whispered in my ear to say I forgot that. It's because otherwise I would never live it down. Okay, that was Julius Volz talking to us about Prometheus. Guillermo, what do you think?
Well, actually, as a engineer, I kind of geek out over statistics and stuff like that. So it does kind of rattle my brain. And I do want to start installing this on everything and seeing what, how many hits I get on my website, which are not that much, since, I don't use my website that much anymore. But, I do want to know in any case. That in my email server, I do have a couple of email servers that I get a lot of spam, unfortunately.
Yep.
So I need to, it would be kind of cool to know how many actual emails are real from the amount I get compared to the amount I receive incoming connections to that server. So I might play around with that and see what happens. As you can kind of imagine, that's why I asked the port question before, because I would need to have that on my side and contact my server through the internet in this case, because I don't have a data center like he has, right? So, in any case, I like the project.
Yeah, it does seem pretty interesting. And I've just, it's one of these things that this is definitely one of those that I want to download and play with right after the show, as I say sometimes in the opening. But I'm definitely seeing the integration, though, because I know, like at ZipRecruiter, there's all sorts of various things around the 100 machines that they have to monitor. And they're building all this glue to bring all these things together. And it seems like, well, why not just have one central system to make that all work? So I like that. Plus, we were going to replace, Nagios with Isinga. But sounds like what I want to do instead is to bypass all that again, and for Insight Cruises, I'm trying to say, and just go straight to Prometheus. So I'm looking at that. I'm thinking this is probably the next best thing, because I love dashboards. I love being able to create dashboards, and I know that if I would have gone with Isinga, I'd have to also then develop, the right stuff with Graphite and things like that. But it sounds like this, again, soup to nuts. Sounds pretty awesome. So looking forward to that. Anything else before we move on?
No, not really.
Okay, great. So we have a couple new people on the short list of people who are going to be on the show. Just coming up next week, just in the nick of time, we scheduled Martin Sustrick, who had been working heavily on the original, ZeroMQ, and then went off to fork his project to be NanoMessage. We do have NanoMessage coming on, but he's no longer involved with NanoMessage. He's now working on something called LiveMill, which allows for Go-style concurrency in C. This is really interesting. He's something like 300,000 context switches a second in C. This is a guy who understands context switching because of all the stuff with ZeroMQ and then NanoMessage following that. So he's on next week, and he'll be on Tuesday. We're moving to the new schedule next week, so that'll be fun. Also just added the schedule, also then going to be on Tuesday, is one of the projects from the Crowd Supply. One of the projects actually got funded and coordinated by Crowd Supply is Tim Ansel, who's making Pneumato-Opsis. It's actually something you can buy right now. It does the recording and routing and manipulating of HDMI and DisplayPort. And it's used for many, many different uses. Actually, he's trying to limit the amount of stuff he's going to talk about in 45 minutes, because he's got a few dozen people who are actually already using this to do really, really cool things with HDMI and all that sort of stuff. And it's basically a FPGA, so you can make it do anything you want. So he's just been added to the schedule. OPN Sense is there. It's a FreeBSD-based firewall. It's a fork of pfSense, which in turn was a fork of MonoWall. Dart, we've got the lead of the Dart project, Casper Lone, with a special co-guest, but we don't know who that is yet because they're still working that out, and also Caddy, which is a high-performance web server written in Go. Now, if you go to the big spreadsheet linked from our homepage, twit.tv/floss, you can see who else I'm working with. I've got a bunch of people right on the really short list. We're just trying to figure out the exact date that they're going to be available. So I'm pretty sure I'm going to fill my entire Q4 within the next couple of weeks, which would be really nice. But we could always use more guests. So the way to do this is you email the project leader, if you're not the project leader already, and then have them email me, merlin@stonehenge.com. That's how it happens. Don't tweet at me. I'm looking at you, Benjamin Carranza. Don't tweet at me. Email me, okay? That's how you get on the project. That's how you get on the list. We have a live stream at 8 a.m. Pacific time. Currently, this is the last Wednesday show. We're going to be moving to Tuesdays. It's at live.twit.tv. We have questions from the audience most of the time. You can follow us at Floss Weekly on Google+. You can also follow the recast of that as Floss Weekly on Twitter. And the Google+ RSS feed seems to be working, although it is a 2-hour delay. So when I post something as on my Google+ account, it's about 2 hours before it hits all the other services. You can follow me at Merlin, MERLYN, on Twitter, and also Randall L. Schwartz on Google+. I don't have anything to plug at the moment. How about you, Guillermo? Anything to plug?
I guess people can just follow me on Twitter, I suppose, at GAMARAL, or look for me on YouTube. Besides that, I think I won't be doing much besides the MakerCon event that I mentioned, which I have not gotten a confirmation yet, so I might not be there. But it's LA, so I might just drive up. Not really a big deal. I think that's it.
Cool. And we're going to end this show just before the lawnmower gets up in front of my window. I said there wouldn't be any lawnmowers today. I was wrong. Apparently, they're doing it out in the rain. Those crazy people. But Guillermo, thanks for joining me. I know you were a little under the weather, so I appreciate that. And as always, you're welcome to join us anytime.
Thank you. I will. I'll haunt you. I'll haunt your dreams.
All right, and maybe I'll see you at the Tequila Festival in Tijuana next week. That might be fun.
Yeah, hopefully I'll be okay by then, because I do like me some tequila.
Indeed. All right, well, and we'll see you all again next week on Floss Weekly.